Hey everyone, in this video I'm going to go over the distance and midpoint formulas that you need to find the distance and midpoint between two ordered pairs. So the two ordered pairs that I'm going to give you at the first are just x1, y1, x2, y2. Now this should look familiar because you do this when you're finding slope. So looking down through here, the distance is going to be found by taking the square root of x2 minus x1 squared plus y2 minus y1 squared. So all you have to do there is to take and subtract. Now if you remember from slope, it doesn't matter the order that you do here. So even though I have x2 minus x1, you could do x1 minus x2. It doesn't matter as long as you subtract them from each other. So if I do x2 minus x1, we'll get that value and square it. And then I would do y2 minus y1, get that value and square it. And I do those first because it's parentheses. And then after I square both of them, then I would add them together. And then I would take the square root. Now, this is coming from the Pythagorean Theorem, a squared plus b squared equals c squared, when you used to find just the value of the hypotenuse. And I'll show you how that matches up in the next slide. The midpoint formula is essentially an average. So if you have 2 points, you can add the two x values together and then divide by 2, and add the two y values together and divide by 2. So the first examples I'm going to show you are just the distance formula. So I'm going to take this and copy it to our next page here. Okay, so this is the formula I'm going to be using. On this page it says find the distance between the 2 points given, and we have -3, 4, and -7, -1. So on your EOC, I suggest that you sketch these. So you'll have a piece of graph paper, and then you can just sketch these on that piece of graph paper by drawing your graph. Obviously it doesn't have to be perfect. You see mine are not very straight lines. So if you graph -3, 1, 2, 3, 4, so that would be -3, 4. I would label it if I was you, and then -7, -1. Let me make that line look a little bit better. So that would be -7, -1. So what we're trying to find here is the length of that green segment. Okay, so what is the value of the length between there? So we're just going to use this formula. So I'm going to rewrite the ordered pairs over here and label them. If this is x1 and that's, y1, and this is x2 and this is y2, then all we have to do is fill it in. So the distance here is going to equal, now I take my x2 and subtract x1, so -7, put it in parentheses, -7 minus, see I'm minusing, and the value is -3. I encourage double parentheses there because the value here is negative. Then I add to that -1 minus, now this is a +4, so you don't have to double up on the parentheses. And then you would simplify. So -7 minus a -3, if you put that in the calculator exactly as it is, it would give you -4, because what that is -7 plus 3, like that. Okay, so the distance, if I keep going here, again, that's going to be -4 squared plus, that's a -5 squared. And the distance there is going to be -4 squared would be a +16, and -5 squared would be a +25. You should never get, sorry about that, you should never get negative numbers under there. Okay? So right here, you're going to have the distance equals the square root, and then we do 25 plus 16 I'm going to do that in the calculator here and show you how I use the answers there. So I get 41. So the exact distance is the square root of 41. A lot of times it will say approximate distance, and you have to take the square root of 41 to get approximately. So the square root of 41, you can see you put the square root and then 41, you get 6.4 roughly. So it's roughly 6.4 units. So what that means is this right here is about 6.4 units. So maybe in the problem it would say that these are points and we are talking about miles, and you'd have to put 6.4 miles. Whatever unit it is, it's 6.4. Now, let me move this stuff down. Here we go. Told you I would connect this to the Pythagorean Theorem, and here's how that works. If you think about the Pythagorean Theorem, it was a right triangle. So you can see you can make a right triangle out of that right there, and this would be your right angle. You can see the distance here would be 1, 2, 3, 4, and the distance here would be 1, 2, 3, 4, 5. And 4 and 5 is what you got right here for the unit. Even though it's negative, if you do 4 squared plus 5 squared equals c squared, you would still get 16 and 25 here. And then to find the length of c, you would take the square root, which is your hypotenuse. So that's how it all ties together. When you used to use the Pythagorean theorem, now you can use the distance formula. However, if it's that close, you might just want to sketch it out and draw your right triangle and use the Pythagorean theorem, whichever one's easier. Okay. All right, let's do this next one. Didn't give myself enough room. Okay. So here we go. This is a new ordered pairs. So new ordered pairs. I'm going to draw them here. So we got 5, negative 8. And we got negative 1, negative 8. So if you sketch this one, and I say find the distance there, hopefully you should see that that's a horizontal line, and the length is just going to be easy because I can count here the units. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 units. So that's 6 units long, and that would be the answer. If you wanted to confirm that with the distance formula, remember you subtract your x's and you add those to your y's subtracted. So it would be, let's say this is x1, y1, x2, y2, and plug those in. x2 is negative 1 minus 5 squared plus negative 8 minus negative 8 squared. This would be negative 6 squared plus, and negative 8 minus the negative 8 would be negative 8 plus 8. So we would get negative 6 squared is 36 plus this would be 0 squared. So 0 squared is just going to be 0, so the distance is just going to be the square root of 36. And the square root of 36 is 6. So graphing those sometimes helps you because you don't have to do as much work sometimes. Okay. And the last one for the distance formula, we're going to do 0, 3 and negative 2, 9. So go ahead and sketch those again. So 0, 3, let's do that here, and negative 2, 9. Didn't make it large enough. Let's move that line down. Okay, so 0, 3, negative 2, 9. So again, you may want to do the Pythagorean theorem here. So if this is the distance, okay, that's the distance you're looking for, you could draw you a box here and do the right triangle. You can see this unit is 2, and this is 1, 2, 3, 4, 5, 6. So that red distance should be 6 squared plus 2 squared would equal your c squared, which is your hypotenuse. So 6 squared is 36 plus 4, that's 40 equals c squared. And then the exact distance would be the square root of 40. But to do that in the calculator, you could get the approximate distance, which is 6.3. So this is approximately 6.3 units. All right, now let's verify that with the distance formula. The reason you need to know the distance formula is that they're not all going to fit right here where you could graph them. So if I gave you something like negative 36, 1/8 or 35, 1, you're not going to want to sketch that because those 2 points are so far away from each other. Not to mention that this is a fraction. That would be hard to graph even if it was not a fraction. Okay? Alright, so to do this, you're going to label them x1, y1, x2, y2. Here we go. You're going to subtract your x's, add the subtraction of your y's. So we have negative 2 minus 0 squared. Add to that 9 minus 3 squared. Notice these are both positive, so I didn't have to put these in parentheses. Just want to point out that when you have a negative, you need to put the negative in parentheses and then the minus, because that will become a positive there. Okay, so to finish this out, we would have negative 2 squared would be 4, and then we would have 6 squared. So negative 2 is 4 plus 36, which is what we got a while ago, square root of 40, and again that's going to be approximately 6.3. So those equal signs become squiggly to mean approximate. Okay. Alright, the next thing we're going to do is find the midpoint. And we're going to do the same order of pairs here. The midpoint is just essentially an average. You add the 2 x's together, divide by 2, add the 2 y's together, and divide by 2. So if I sketch these, I've got to make those lines better. There we go. Alright, so if we sketch those, we get negative 3, 1, 2, 3, up 4, and negative 7, down 1. So what we're trying to do in this problem is to find the midpoint. So we're trying to find approximately right there. So how we do that is just add them together. So I would do, if this is x1, y1, x2, y2, add the x's. So you could do negative 7 plus negative 3 over 2, and then negative 1 plus 4 over 2. That's going to give you negative 10 over 2, and that will give you 3 over 2, which that would reduce to negative 5, and then 3 over 2. So negative 5, 1, 2, 3, 4, 5, and then that point right there is negative 5, comma 3 over 2, which is 1.5. So negative 5, comma 1.5. This will work the other way. Like I told you before, if I did like negative 3 plus a negative 7 over 2, and then 4 plus a negative 7 over 2, I still get the same result there. Oh, sorry, I put the wrong number here. Get the same result if you do it correctly. So this one, negative 3 and negative 7 go together, and then 4 and negative 1. So I would get negative 10 over 2, and then that would give me 3 over 2 again, which is the same thing. All right, so this one right here. If you sketch those, 5, negative 8. And negative 1, 8. I'm trying to find the midpoint between those two. So you could probably kind of tell where it is. Right there is going to be the midpoint. So this one you could actually do without doing that formula, because it's going to be 2, negative 8. But to confirm that, again, you add your x's together. So I'm just going to do negative 1 plus 5, because it's x2 and x1 over 2, and then negative 8 plus negative 8, and when I put a negative I always double up on the parentheses. So this would be 4 over 2, comma, negative 8 plus the negative 8 is negative 16 over 2 is negative 8, so that would be 2, negative 8, which is what we thought it would be. Right, and the last one. Can you do these without sketching? Absolutely. You've got the formula. That's what it's there for. Remember, they may not give you this easy of numbers. It might be really large numbers that you can't graph easily. So you add negative 2 plus 0, negative 2 plus 0 over 2, and then 6 plus 3 over 2. 6 plus 3. So that would be negative 2 over 2, and that would be 9 over 2. So your answer should be negative 1 and 9/2. Again, you can do this without graphing, but it kind of keeps you in check. If you do sketch them, you might find a mistake that you might need to fix. So if this is 0, 3, and negative 2, 6, right there's the midpoint, negative 1 and 9/2. Is that logical? Absolutely. So sometimes maybe, if you messed up in your sign, you might get 1, comma 9 over 2, and that would be over here. And that's not even on the segment, so you could catch a mistake doing it that way. So that is the distance and midpoint formula. Please watch this video, pause it when necessary, look back at the examples that I gave you.